Thank you. I'm Mr. Lehner, and welcome back to Mr. Lehner's Math Extravaganza. In today's webisode, we're going to continue to work with factorization and factors and how we can actually use that to solve some real-life, everyday situations. So, let's take a look at an example problem up here. In our example problem, it says, Jeremy and Jenna work during the week and on weekends doing jobs around the neighborhood. It must be really nice. They are paid by the day and not by the hour. They each earn the same whole number of dollars per day. Last month, Jeremy earned $184 and Jenna earned $207. How many days did each person work? What is their daily pay? Seriously, Mr. Lehner, you're giving us this problem to do? This brain buster that's so impossible to work on? Well, yeah, actually I am going to give it to you. But we're going to break it down step by step to make this a little bit easier to figure out. So, I know that they work during the week and on weekends doing jobs in the neighborhood. Okay, that's okay information there. I know they're paid by the day and not by the hour. That's helpful. I know that they earn the same number of dollars per day. So if Jeremy earns $20 a day, Jenna earns $20 a day. So whatever amount they earn, it's the same each day. I know that Jeremy last month earned $184 and Jenna earned $207. Okay, so now I know how much they earned in the week. How many days did each person work, and what is their daily pay? Okay, so there's a lot of information here. Let's take a look at how we can solve this problem. I'm going to start off by looking at the factors. I know that if they're working in 1 month, the maximum days in a month is 31. So let's say if they earned $10 a day and they worked all 31 days, that'd be $310. Well, I don't know if that makes any sense. How can I make this a little bit easier for myself instead of using like guess and check? Well, factors. Let me look at the factors of both numbers. If I use the factors of 184 and 207, I know that 1 and 84, 2 and 92, 4 and 46, and 8 and 23 are all the factor pairs of $184. Let me find the factor pairs of 207. 1 and 207, 3 and 69, and then 9 and 23 are the factors or factor pairs of that number. Well, let's see what they have in common. They each have $1 in common, and they each have 23 in common. So, how do I know which one to choose, Mr. Lehner? They're both common factors here. One are common factors between both of these numbers. But when looking at these and taking a look at one, well, does it make sense to say that they both earned $1 each day? I just mentioned that it was a month. Well, if they work 31 days every single day in the month, and they each earn $1 a day, they would earn $31 at the most. Well, I know that Jeremy earned 184 and Jenna earned 207, so one would not make sense to use, even though it's a common factor between both. Well, let's look at 23 then. If I look at 23, let's see if this works. If Jeremy worked 8 days and was paid $23, 8 times 23, 8 days times $23, he would get $184. That would make sense. He'd work 8 days in a month. If he got paid $23 each day, he's making pretty good money there. Let's look at Jenna then. If Jenna worked 9 days, 9 days times 23 would equal 207. So they each earn the same number of dollars each day, which is 23. Jenna worked 1 extra day than Jeremy, so that's why she had more money. And this shows why he earned $23 in 8 days, and she earned $23 in 9 days. So again, I was using my common factors this time instead of common multiples. I used the common factors to show how much they earned each day. Now, if I were like a 6th grader, that's pretty good. If I can earn $23 a day just to do some chores here and there, I might like getting paid $184 in a month. I'm sure you would at home, or even better, you might like to make $207 in a month doing some of these odd jobs around the neighborhood. Okay, let's take a look at another problem. Darius and Kim work at Hazel Green for the month. They are paid by the day, not by the hour. They earn the same whole number of dollars per day, so similar to what we were just talking about. Last month, Darius earned $87 and Kim earned $116. How many days did each person work? What is their daily pay? I know you got the pencil and paper ready to go. Go ahead and pause the video and we'll see what you come up with. Alright, I bet some of you might like this job too. Imagine Miss Humphrey offers you guys a nice little job to work after school and you can make some of this money. We'll see. Let's figure out. I'm going to start off by listing some of the factors. You may have chose a different strategy again, that's perfectly fine. But I'm going to list the factors of 87 and the factors of 116. I know that each has $1, but similar to our previous problem, $1 is not going to make sense because they did it in 1 month. There's not enough days in the month for it to equal 87 or 116. Their common factor right here is 29. So I know that Darius has worked 3 days and he was paid $29 per day because 3 days times $29 would equal $87 total, which is what he earned. And Kim worked 4 days because she worked 4 days times $29, which would equal her $116. So I figured out that each one earned $29. Kim worked 4 days and Darius worked 3 days. Again, that's pretty good pay. If you're going to pay someone $29 an hour, like I said, maybe convince Miss Humphrey to help out at Hazel Green, maybe earn $29 a day. Good luck with that, but it might be a really good choice to try and get her to have you do that. But again, using my common factors here, I was able to figure out how many days and how much they got paid per hour. Like I said, maybe you can show her this video, negotiate having you work at school and earn that much money. I don't know if it's going to work, but it's worth a shot. Thank you for tuning in to Miss Linder's Math Extravaganza. As always, we'll see you next time.